Hello everybody, this is Mr. Folly, and welcome to 5.1, where we are going to talk about balancing equations. Alright, so balancing equations. Balancing equations is done to show that matter is neither created nor destroyed. This shows the law of conservation of mass. Okay? That means that particles can't be created nor destroyed. So that means over here, if I have 2, 4, 6 hydrogens, over here I have to have 1, 2, 3, 4, 5, 6. That can't happen, right? Some H's and some Cl's just disappear. The world doesn't work like that. The world works like this. So if I have 2 H's and 2 Cl's, I'm going to come up with 1, 2, 3, 4, right? So that's going to have the same number of atoms on both sides, okay? All right, so this actually should be a little more, oops, let me get my colors back. Let me get my green. They should be separated, so I should have an H separate from C. Okay. That was pretty easy, but drawing circles gets pretty slow and annoying. So let's look and see how to do the harder one. So this is what I heard called an atom inventory. Okay, so what I'm going to do is I'm going to count out how many carbons there are. On the left-hand side, I have 1 carbon. On the left-hand side, I have 4 hydrogens. On the left-hand side, I have 2 oxygens. On the right-hand side, I have 1 carbon. On the right-hand side, I have 2 hydrogens. And on the right-hand side, I have 3 oxygens. Okay? So I put them in the same order. Cho. Note how an atom can be in multiple places. Boo. Right? Okay, so look and see which ones are not equal. So carbons are equal, hydrogens are not. So you want to start with the easiest ones, okay? So the H's don't balance. The only thing I can do, so notice they don't balance because 4 versus 2. The only thing I can do is add a coefficient, that's a number in front, okay? So if I put a 2 right here, that would now give me 4 hydrogens, right? And it would give me 2 oxygens plus 2 oxygens, which is 4 oxygens. Still have 1 carbon. Okay? So I'm still at the same spot over here, same numbers, 1, 4, 2. Okay? This coefficient multiplies through, so now notice my hydrogens are good. Okay? This balances the H's, but not the O's. Oh no. So remember, I've got this right here. So to balance my O's, I want to have 4 on both sides. So what I'm going to do is drop a 2 right here. If I do that, that's going to give me 4 O's. I still have 4 H's. I have 1 hydrogen, and I'm still at 1, 4, 4 over here with that. Just balance the H's. So there you go. Okay? So we just keep going until they're all balanced. Here it's all balanced, and we're all done. I must have skipped a spot from what I was thinking. Let's do another. So, to start with, I guess here's another one that's already balanced. 2 NAs, 2 N's, 6 oxygens. Over here, 2 NAs, 2 N's, 4 O's plus 2 O's is 6 O's. Okay? So that's it. There's a sample one. Let's see if we can do one. Hey, it all worked out. Let's try this. I'm going to do this without doing the counts. So how many H's do I have on the left? 2. How many H's do I have on the right? 2. How many O's are on the left? 2. How many O's are on the right? 1. Uh-oh, so I'm going to put a 2 here. Notice how this causes some problems here. Oh no, now I have 4 H's. So I had to mess up my H's to get my O's right, but I can put a 2 right here. So this gives me 4 H's, 4 H's, 2 O's, 2 O's. Turn that frown upside down, my friend. So you can make it mess up a little bit to get right here. 2 N's on the left, 1 N on the right. Fix that. Now I have 2 nitrogens. I have 2 H's on the left. I have 6 H's on the right. 3. 3 times 2 is 6. And I'm all set. Alright, so here comes the hardest one. And their combustion reactions, you learn what those are in a little bit. They get a little tougher because you got oxygen in 2 spots. I have 4 carbons on the left. 4. I have 10 hydrogens on the left. Uh-oh. To get 10 hydrogens over here, put 5. Okay. Over here I have 2 oxygens. And over here I have 8 plus 5 is 13. So if you notice, there's not a number on Earth that I can put here, whole number, that can get me 13 oxygens. So what you do, when you're stuck, dun, 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 you have some choices. 1, double the big guy. Oh, not double, I'm going to change that double to, raise the big guy by 1. Okay, so who's my big guy? Well, C4H10 is the biggest one that's out here, right? So right now it's 1, so I'm going to change it to a 2. So if I put a 2 right here comes the trouble. And because I have to do this, I'm going to start keeping track now. So I'm going to do my CHO. So my starting point, I have 4, just without my coefficients. H is 10, and O is 2. And over here, C, H, and O, before I put a coefficient in there. So just 1 C, and just 2 H's, and 3 O's. Okay. So what I just did to start with, because I tried it and I got stuck, right? I had to double the big guy, so put a 2 right here. 2 times 4 is 8. 2 times 10 is 20. Let's do my carbons over here. How do I get 8 carbons? Put an 8 right here. 8 carbons, and that gives me 16 plus 1. 17 oxygens. That's not looking very promising. I want to get 20 hydrogens. I put a 10 here. 20 hydrogens, and then I have 10 H's plus 16. Oof, it's 26. Oh, crud. What can I put right here to get 26? I think I can do that. That's 13. So my coefficients will be 2, 13, 8, and 10. We'll do more of these and talk about it more in class, but that's it. So,